This is the training objectives. A competitor shall weld root pass with the specified welding process according to the provided drawing for a 10T pressure vessel. Task: to weld the root pass of a 10 mm pressure vessel. Objective: to complete root pass welding for a pressure vessel with the specified welding process. Goals: to strengthen welding skills for the pressure vessel. To make a sound weld without any welding defects such as undercut, overlap, and so on. Materials: for the pressure vessel, use a 10 mm plate, 400 mm in length, 300 mm in width, and 350 mm in height. For welding rods, KH500LF, KC28, K71T, and T50 are used according to the welding technique. Main focus of the task: competitors shall weld pressure vessel with the indicated welding process on the drawing. Make sound welds without any defects such as undercut, overlap, and porosity while root pass welding. It is important to deposit beads without fusing of the groove edge for the butt and corner joint. If a big amount of welding beads deposit on root pass, cap pass welding will be difficult. Making thin and even root pass is important than building up root pass fully. Covering the end point of root pass completely with welding beads is important. When the root pass has excessive reinforcement over the surface of the base material, remove the root pass by grinding. For the stop-start, start an arc in front of welds and bring it back to welds rather than starting an arc on the welds to prevent overlap. Making all-around welding along with pipe is important for pipe welding. Keep bead height as minimum and deposit uniformly. Please check the preparations and tools for this training. Precautions: when welding with a technique different from the drawing in each part of the pressure vessel, it is excluded from scoring. So, mark the technique in advance not to use the wrong technique for starting the work without mistakes. When welding the root pass, it is necessary to grind off the excessive tacks that become an obstacle to the welding process before working. Set the point where welding bead to be deposited and weld by weaving side to side, then make the bead line. Cap pass welding might have a problem when face reinforcement of root pass is higher than cap pass. Therefore, keep bead height of root pass at 2 mm lower than surface of base material. Make the thin root pass with FCAW process to make stable cap pass, since higher welding current and fast travel speed are used for FCAW process. Root pass of pressure vessel shall withstand hydro pressure test. Make sound root pass to prevent any leaks. When weaving during root pass welding, never touch the end of the improved surface. Be careful not to melt the edges, as the ends of the improved surface become the reference line for stacking surface beads. Remove spatters with a hammer at once. Make sure several times of hammering could make indentation on pressure vessel. Please check the tasks to perform. Preparation for root pass welding. Right type of welding process to be used for each joint after reviewing the drawing. For the pressure vessel welding, 4 welding process to be used: FCAW, GMAW, GTAW, SMAW. According to ISO standard, dedicated number is given for each welding process. 111 is SMAW process. 135 is GMAW process. 141 is GTAW process. 136 is FCAW process. When different welding process than the specified on the drawing applied for pressure vessel joints, the joint will not be accessed. Welding could be commenced without any mistake by writing down the required welding process in advance to avoid any mistake. Butt joint welding. For root pass welding, welding sequence is very important. Generally, weld butt joint first, corner joint followed, then weld fillet joint as last. Weld butt joint with the FCAW welding process. Weld the joints with FCAW backhand technique. When root welding with the FCAW process, fill up a large amount of weldment at once. When butt joint welding with the FCAW, grind off the excessive tack welds which may turn to an obstacle because of the fast welding speed. When welding for root pass with the FCAW, the start point is important. Set the size of welds considering the amount of weldment and make uniform weldment from the start point to the end point. Finish the welding by making 2 or 3 spot welds. Remove slag by grinding and cleaning up contaminants with a cup brush. Remove spatters on weld area with a chisel and hammer. Remove splatters with a single hammering. Be careful, hammering several times may make notch indentation on the pressure vessel. This is a vertical butt joint. Weld the joint with GMAW 135 process from the bottom to top. Prior to welding, grind off the tack welds which may create an obstacle. Root pass of pressure vessel shall withstand the hydro pressure test. The weld joint need to be filled up with weldment securely to prevent any leaks. Weave in a semicircular or in a zigzag pattern and fill up the weldment completely by pausing at each edge. For the end joint, spot welding until the weldment is deposited completely up to the corner joint. Consider it as filling the gap between 2 plates by welding. Corner joint welding. Weld corner joint with the SMAW 111 process. Use welding electrode KH500LF 4.0 mm. Welding current is about 135 ampere. Strike an arc at the starting point and align weld with tip of corner line, then start weaving when arc is stabilized. In general, the triangle weaving making triangle shape is mainly used. Triangle weaving is the way to move forward and backwards repeatedly, like drawing a triangle shape. Due to the limited length of welding electrode, stop-start cannot be avoided. 80 to 100 millimeter length of welds could be made with one electrode. Remove slag on the welding bead with a chipping hammer whenever one electrode consumed all. For a stop-start of SMAW process, strike an arc in front of welds, then bring it back to welds making U and connect welds when the arc has stabilized. This is the method to prevent excessive reinforcement or overlap. To complete the task, the proper time should be assigned for each stage. To reduce working time, minimize grinding work. While weaving, reach the groove edge by no means. Do not fuse the edge of the groove because it is a guideline for cap pass. After completion of welding, remove slag on bead completely. This is horizontal corner joint welding. Weld the root pass with the SMAW 111 process. If the joint is too protruding, it is better to grind it with a grinder to remove the welding obstruction. Strike an arc at the starting point and align weld with the tip of the corner line. Then, start weaving when the arc is stabilized. Deposit the weldment up to the corner edge and progress with the triangle weaving technique. For the SMAW process, make a keyhole that is small enough to prevent burn-through in front of the weld, and progress welding. Weaving the welding rod slowly while staying on both sides of the corner, little by little. Remove slag on the welding bead when one electrode consumes all the weldment generated. Start welding with new electrode and make bead connection. For a stop-start, strike the arc in front of welds, then bring it back to welds making U and connect welds when arc has stabilized. Weave carefully in order to avoid slag inclusion or weld defects. Allow weldment to be deposited up to the edge of the corner joint, then finish welding. Edge joint welding. Weld edge joint of the vertical corner area. Weld the joint with the GMAW 135 process. Grind off the excessive tacks prior to welding. The oxide layer needs to be removed prior to welding since GMAW makes shallow penetration, and also it is a sensitive welding process. After grinding works, clean up contaminants with a cup brush. Check up to where the welding bead needs to be filled and make the weld align by weaving the torch side to side at the start point. The weave should be in a semicircle or in a zigzag pattern. The tip of the wire should pause at each edge and deposit the weldment. Maintain a 3 to 4 millimeter weaving pitch while welding. While weaving, do not let the edge of the corner get melted. The edge of the surface is a guideline for the cap pass. The most important thing is to maintain the bead line of both edges. The reason why different welding process applied for pressure vessel task is to demonstrate similar condition with the actual fabrication site. Deposit beads fully up to 1 to 2 millimeters lower than the surface. Deposit beads at the endpoint fully as well. It is an inclined vertical fillet joint. Weld joint with the FCAW 136 process. It is not recommended to deposit a big amount of beads with the FCAW for fillet root pass. A stable cap pass is possible when a thin root pass has been made with the FCAW because its travel speed is fast and its welding current is high. Pipe welding. Weld the joint with the SMAW 111 among 4 welding processes. Weld from 3 or 9 o'clock position to 6 or 12 o'clock position clockwise based on the front view drawing. Making round welding along with pipe curve is important for pipe welding. Keep bead height as a minimum and deposit uniformly. Weld the cover plate of pipes with the GTAW 141 process. This section is about mild steel welding. Be careful that the edges of the groove are not melting and weld along with the pipe radius while maintaining a short arc length. At this point, while keeping the angle of the filler metal to the weld line at about 10 to 20 degrees, make weld by pushing to the front towards the torch where an arc occurs. Put the nozzle on the V-groove and travel by moving the torch in a half moon or a zigzag pattern for weaving. Weld root pass of the pipe butt joint with the GTAW 141 process. Pipe-to-pipe connection is pipe butt joint. The weaving technique for the connection part for the cap plate and the pipe is slightly different. Welding for pipe butt joint proceeds very quickly by weaving the ceramic nozzle of the torch at the top of the groove, whereas zigzag pattern weaving applied for cap plate welding. Be careful that the groove edge of the pipe joint is not melted, and deposit welds by feeding filler metal uniformly to make even bead height. Checking the condition of welds. After completion of root pass welding, check the condition of welds. Check whether the edge of the vessel has been welded. If the edge of the weld joint melts and disappears, the cap pass welding is going to be difficult because the welding guideline is not able to be confirmed. Cross-check the actual and the drawings and confirm if the weld joint made with the welding process indicated on the drawings. If a different welding process applied against the drawing, the joint will not be accessed. Please check the key points of the tasks you have done this time.
한번 체크해 보세요.
So far, we have learned about the construction of the root pass of the pressure vessel. Thank you for your hard work.